Okay, excellent. So welcome to my session, Building Machine Learning Models in SQL Server 2019. My name is Nisal Mihiranga. So let me quickly introduce myself. I'm a business intelligence consultant and trainer in Sri Lankan based. So I do community works like tech talks, training programs, and you can connect with me using these social media links. I'm active in Twitter and LinkedIn. So the audience will be in this session basically the data analyst. So I'm sure you are from related backgrounds, maybe data engineers, data analysts, and people who are from data science, maybe. Uh, so today in this session, I'm going to cover these things. First of all, we'll talk about machine learning. I'm not going to go in detail into the machine learning like theory part, like what is classification, what is clustering, those things, because my session objective is to talk to more in detail into the SQL Server 2019 and see what are the features they have offered in order to do the machine learning models. And we'll talk about the evaluation of the machine learning in SQL Server, data science lifecycle, and we'll do a quick demo on how to build a machine learning model in SQL Server. So in the machine learning simple term, I hope you already know about these terms. What is machine learning models? It's a model which can used by computers to take certain decisions based on the learning. So rather, we are forcing using the programming statements. We are building a models to train machines or computers to do certain decisions without human interaction. That is essentially the definition of machine learning. So let's talk about how, if you are going to build a machine learning model, how it looks like and how we can do in the normal pattern or in the traditional way of building a machine learning models. So this is a typical application. It's a business applications. So we know that there are applications. So those applications read data from the databases and write data back to the DBs. So if you are doing a machine learning model or building a machine learning model for this application, we know that we need to maintain a separate analytics server or separate environment if you are doing in the traditional way. So that is where mainly the data transformation, data modeling, and certain similar tasks are happening. And also the we had to do the scoring. Scoring means the evaluating the model and use the machine learning predictive model in order to take the results. Scoring is the word we are using in the data science space to do the evaluation and the testing the machine learning model. So for that also we may need to use the new data. We are training the model using existing data with the results, and based on that the result we are testing with the new data to get the predictions for the future. So that is essentially the how we can build a machine learning model. So even this machine learning model we need to implement or deploy in the separate server or maybe in the application server in order to integrate with the application. That is how the life cycle is happening. Like once we build the machine learning model in the maybe a server, we need to deploy in the production server with integrate with the our business application in order to consume that resource for the business users or end users. So this is how the traditional way of doing machine learning. But with the SQL Server, what they have provided, they integrated with the machine learning languages and the framework, which we can do the machine learning tasks inside the database. So all the data transformation and the data modeling and scoring part we are doing as is inside the SQL Server database. So this is allow us to make the lot of flexibility in terms of the data governance because in the legacy method or traditional method, uh, in if you look at this architecture, all the this data we need to move here and there, then there are certain securities we need to implement and we need to take care of. But inside the since in the machine learning services in the SQL Server, all the data resides in the SQL Server database. So if our application is writing data into the SQL Server database, we can use same database or same database server to perform machine learning tasks and training data, transforming data, and do the predictive analytics in the same server. So the security in terms of the security aspect, it's using the same security as the normal database security. So DBS, they can enforce their data security in the same way we are doing. So this is the difference comparison between the traditional machine learning and how we can do the machine learning using the SQL Server. So let's have a look at the evaluation of the machine learning support in SQL Server. So Microsoft SQL Server, they introduced R support in the SQL Server 2016. So they name it as R services. The subsequent release in the SQL Server 2017, they integrated Python. That is where mainly R and Python are the main two languages data science community they are doing the performing the machine learning tasks. So they integrated Python. So since both R and Python is there, so they rename it as a SQL Server machine learning services. So in the SQL Server 2019, what Microsoft offers, they integrated Java, the Java support to the SQL Server, so we can perform similar tasks using Java, data transformation, and a lot of tasks which we are it's hard to do in the traditional way. We can use Java language to do certain performing certain tasks. So what we call this as a SQL Server language extensibility. So this support both three languages are Python and Java. So what I see the real advantage is T-SQL is a set-based language. So in order to do certain tasks, programming tasks, we need to do specific actions to do like loop in data and so on. But having the support of Java, and if you have a team members in your team who are from the programming background, so we can collaborate with them and perform these tasks using Java, because it's really easy to do certain tasks in using programming language like Java. And also so the session done by previous session for the cognitive services, so similar tasks like calling cognitive service web API, we can use Java language to call that cognitive services machine learning, taking the machine learning results back to the our SQL Server database. So that is where the lot of flexibility I see in this integration. So why Java? Java is one of the top community-based popular programming language even now. So supporting Java language into the SQL Server 2019, it's allow more users to engage with it, and also that SQL Server 2019 it support Linux version of the SQL Server. So which means it's giving the more open the more community to the open source community, both Java and Linux, to do those integrations and applications development. So let's quickly look at the data science process or data science life cycle. So first of all, what we do basically before we implement the data science predictive model, we do exploring the data. So for that, we have the flexibility of using either R or Python or T-SQL standard T-SQL language to do the data exploration. That is where, because I am from data database background, from the data engineering background, so I know more on T-SQL than other language. So we can do those things without uh, moving to a new language to do the data exploration part. That is where we have been doing so far. So next thing is that once we explore the data and identify the attributes for implement the machine learning model. So we can build the machine learning model using either R or Python or also Java to with the SQL Server 2019 to build and train the machine learning model. That is where the data scientist work role comes into the play. So once we develop that, then we have to deploy that into the production server or application server by integrating with the business applications. Because once we build a data science or machine learning model, we have to deploy into the production server or with the integrated with the business applications. That is then only business users can consume that application. So then the final step is to app developer or application developer can integrate use this result predictive machine learning model result with their application and allow the business users to consume the machine learning model. So where I see the lot of flexibility in here in this diagram, because even the deployment, so you see the role is the SQL developer or DBA who can deploy the machine learning model. So when you're going to deploy the EC, I will show you in the demo at the later. We can do we can write simple standard T-SQL stored procedure to uh, and execute in the our database. So we can share that SP with the application developer. They can consume that. Similar to the traditional application development, they can use that standard stored procedure to pass parameters and get the results. So that is where I see the reduce the complexity of the machine learning model development in the SQL Server. So let's see the extensibility architecture. So in this, what we say it's as a extensibility architecture. I will explain the next slide, the architecture. So initially, as I said, SQL Server introduced R runtime or R integration. So after that, they adapted with the Python support in the SQL Server 2017. Uh, so the basically the purpose of providing this interface to this architecture to provide the interface between the SQL Server and data science languages like R or Python. So adoption of the Java support in 2019. So now they have support 3 languages to do the machine learning and other data engineering related tasks. So basically what we are doing, once we enabled it or installed it in our server, we have to run external scripts execution into in order to make that perform that task. So the security of that executions also the subject to the SQL Server, which means the same security appliances or same security methods we use to grant normal traditional database objects. Similar things we can similar way we can perform the security in the this extensibility architecture. So the next one is actually this is a very important thing. So you know that our language is an open source language. So it was there from the beginning, even 90s. Uh, what Microsoft they have done, they have integrated or incorporated our language into the SQL Server. While they are incorporating that, what they have done, the beauty of it is because earlier the R open source is a single threaded programming language. So no matter how large the data set is, it's always need to we have to fit into the our memory available memory. So if your personal computer memory is 8 GB or 16 GB, we can't process or train a model more than that volume in terms of the data set size. So in the while adapting the R or Python, especially R, what Microsoft they have done, they have pushed those limits, and they have make the R as a multi-threaded programming language. So we can do parallel processing or batch processing using this R, Microsoft R. So that is where this Revo SQL R framework. If it is Python, Revo SQL Python. These frameworks, two frameworks comes into the picture. So we need to do we can do a lot of things like processing big data or on top of especially implementing machine learning models for the big data. So it is very useful. So let's have a look at the extensibility architecture. So this is where our SQL Server and other machine learning services there. So you can see in the SQL Server, first of all, what you are doing whenever we are calling these machine learning, executing machine learning codes in the SQL Server, what you are doing basically, we are called we are passing parameter as a parameter the language we are using, whether it's a R or Python or Java. So we are sending the request by indicating the programming language via a parameter and send to the request to the launchpad service. So launchpad service start at the appropriate launcher. So if it is the R we have passed, then it's open the R launchpad, or it is Python or Java, respectively, they open that particular launchpad. So then what we'll do basically, it's start the external process and with the R services. So there's a service called BXL server, which coordinate with the R runtime in the R services with the SQL server to exchange the data basically. So basically a lot of data transferring happening because we are passing data, we are passing data in order to training the model, and while we are scoring the data, we are passing certain parameters to get the results, so on. So this is where the data transferring happens using the BXL server. So there is another service called SQL Satellite, which basically responsible for the manage the communication in between these tasks and processes and the SQL Server. So once the job of these services is done, what they are doing basically using standard TCP/IP protocol, they are moving data back to the SQL Server. That is where we see the results of our prediction model. So from the SQL Server, we can do whatever things. Basically, we can even show the data by querying, or we can write back into the database, or we can perform certain things. So if you are some of you are new to the SQL Server, or who are supposed to install the machine learning services, this is how you can install. So this in the SQL Server 2019 setup. So when you are going to in the wizard, the feature selection, you can select the under these machine learning services and language extension, you can choose either language. So in my case, I have initially installed R and Python, then I have installed Java as well. So you can install like this in your machine. So just installing these machine learning services is not going to enough, because this is if you can remember the extensibility architecture, these codes are running outside of the service SQL Server. So where you need to enable this configuration, or configure this to make external scripts enable in order to execute your R or Python or Java code in your SQL Server. So this is a sample code. If some of you are familiar with the R language, so in my case for the demo I have used R language. That is where I mostly preferable. If you are familiar with the Python or Java, you can do the same similar tasks using those two languages. So in this code, what I have done, I have it's a simple code. I have assigned two variables A and B. I assigned one value one for A and two for B, and I created another variable called C, and I have done a simple addition summation and print the result. So if you are going to execute this code in traditional R Studio or some traditional way of you are referring R, you can simply write this code and in the command from R console and get the result. So in addition to what you have to do, you have to wrap this as a string or in the variable and pass into the these by invoking this sp underscore execute external script. You need to pass this code, then you will see the results. So let's run a quick demo how we can enable the R and how we can write this execute this R code in our SQL Server 2019. So this is my SQL Server instance. So either you can use usual management studio or even Azure Data Studio is also possible to execute these codes. So in my case, for the demo, I have used Azure Data Studio. So I have opened a new notebook. So you can open a notebook from here, either query, a new query or new notebook. In my case, I have opened a new notebook. So to make the more visible for the audience. So in this first command, what I have done, I have enabled this configuration running external scripts in the SQL Server. So let me run this. So it will take few seconds. So configuration option is changed to 1. So I have already enabled this. So that's fine. So in this next command, the second command, what I'm doing, basically I have similar to the slides, I have created a few variables, and I'm doing the multiplication and division. Let me run this code and see the result. Okay, so you can see you can get the results like this. So there is another command I have written. These are some standard commands we can use. In this command, what is basically doing, it's return all the libraries which installed under this R framework in SQL Server. So this is the location, and these are the libraries or packages with the versions. So let me go back to my slides. So up until now, we discussed the R support of SQL Server 2019 and what are the features and how the data science life cycle works, and how we can, if we are going to implement a predictive model, how we can implement that, and what are the main steps we need to perform in order to implement that. So let's talk about a business problem. The second demo I'm going to use run today. So it's based on the HR attrition. So as you know, anytime when an employee leaves, it's cost for the company, because if the company knows in prior to that they are leaving, so they can do a set of certain tasks in order to make a decision. So if we can analyze these data, so like attrition data or previous data of attrition, and if you can predict that the the possible attrition of the employees in an organization, then the company can take certain actions upon that. So in my business case study, what I have done, I have used this data set from Kaggle, IBM HR Analytics Employee Attrition and Performance. So you can go to this link and download this data set. So if I'm telling about Kaggle, Kaggle is the one of the largest open online community for the data science. So there are data sets, there are a lot of data science users who, even the new users, they can learn how to do the machine learning, and they can refer existing codes from the experts, and they can do their own codes and publish it. And there's a leaderboard. They are rating your work based on the accuracy and certain measures. So it's a good way of good place to learn machine learning if you are jump into the data science or machine learning in your career. So in my demo, I'm going to use this data set, and I'm going to predict using simple linear regression algorithm. I'm going to predict the attrition, the possibility of having attrition. So this is my notebook I have created. This is nothing much but the same course I can write inside my SQL Server Standard Management Studio. So first of all, let's observe the data set. So it's contain 1,470 rows or observations. So in these data sets contain age, attrition, whether that particular employee is resigned or not, and the business travel, department, distance from home, education, employee count, employee number. This is where we can locate that particular employee. So these are public data set. There is no sensitive data like their names and so on. So environment satisfaction, gender, hourly rate. So these are the data set. It's contain more attributes like job satisfaction, monthly income, overtime, percent salary hike, percentage of salary hike, performance rating, and so on. So you are going to use this. And here what I have done a simple standard T SQL command to identify to split the data, because as you know, when you are implementing a predictive model or machine learning model, we need to have two data sets, basically train data set and test data set. Train data set is where we are going to we have the data set with the labels, or rather the results we are going to achieve. We are passing that entire data set with the results and train that data model, machine learning model. And again, we need to have a test data set where we can evaluate or score the machine learning model. So in this case, I'm going to split the data into the 70% and 30%. 70% for training data and the 30% for test data. Actually, you can use, there are certain libraries or functions, built-in functions you can use to achieve this task, like sampling data or splitting data into the training data set and test data set. In my case, what I have done, I have used simple is equal to find the number of records for the 70% and the rest of the as a 30%. So in this code, this is where we are going to create the machine learning model. So in here, what I have done, I have used generalized linear model where it's fit for the predicting the probability of the attrition. So if I explain this standard, if you are familiar with the writing stored procedures in SQL Server, this is standard way of you can write stored procedure. So similar syntax. So in here we have execute this sp execute external script stored procedure inside this in order to pass this code R code into the R service or machine learning service. So in here script, this is the formula or the formula for the predictive model or machine learning model. So in the formula, what it does, what it says, I need to predict the attrition based on these parameters. This is how you can write. This is similar way you can write for the other classification and clustering algorithms as well. So in here, and the next one is the input data set. So here I have used my input data set from using the same table. So this is where I see the lot of flexibility. Even though I know the R functions. So since I am more even everyone familiar with the SQL, so you can use SQL to do certain tasks without writing R functions. So in here, what I have done, I have write a simple SQL statement to pass this value my train data set. So this is my input data set, and this is my output data set. So here let me run this code. So it's ran successfully. Actually what it does here, it's define this stored procedure, the generate GLM attrition. This stored procedure, it doesn't execute it, right? So let me create another table, create a standard T-SQL table in order to hold or store this machine learning model. So here what I have done, I have created a table with two fields, one for the name, and I have created a column with the var binary data type in order to store the machine learning model in my table. Let me run this code. So it's created. So here where I am going to actually execute this the above stored procedure, and the return, it will return the data model, predictive model. I'm going to store that in or insert into this table. It's ran successfully. Since I have used the data set, my data set is it's around 2000 records, but if your data set is more than that, or 10,000 or 100,000, it will take a certain amount of time to execute these commands. So let me execute this and see how it looks like once. So this is my table, my model, and this is my table we are storing the machine learning model. So I'm going to rename this model. Now I'm going to do, so I have trained my model and already stored in my SQL Server. So the next step would be, I'm going to create another table in order to store the data set, my test data set, or rather scoring data set. So for that, I have created a table called score attrition with the similar set of columns. So here I'm going to pass my filter my data, my test data into this table, newly created as score attrition table. So it's already inserted. So let me check. So this is my table. So you can see here my attrition column is the column attrition value is the value I'm going to predict using this machine learning model. So because of that, I'm not going to store any value in here. So let me check quickly. Seems like there is an error with my not the code in my service. Let me check whether I can fix this quickly. Let me check. Looks like there is an error with the Azure Data Studio. Let me run this code in my standard management studio. So in here, what I am going to do, I'm going to so this is my table which I was explaining. Next thing is let me this is my data model. So here this let me run this code. So before I execute this code, let me quickly explain this code. So here I have created a binary variable and I have stored this machine learning model into this variable. So in this R code, what I have done basically, I have unserialized that my model and created a new variable in R and created a data frame using this score attrition dataset where I'm going to load in here. So you can see this code. So basically, I'm using this predict attrition. This predict is the function where I'm going to pass this data model and new data set. So here, let me run this code and see what would be the result. Basically, I should be able to get the percentage value of a probability for the attrition. Let me run. Okay. So it ran successfully. So this is my test data set, and these are the probabilities or prediction predicted attrition for these. So based on that, we can decide uh, uh, whether certain employees are going to resign or not in future. So let me go back to so actually I want to tell that what where I see a lot of flexibility, because inside this machine learning, while I am building this machine learning model, I was able to use my standard SQL knowledge, where splitting data and even transformation, because in here I haven't done any transformation. So in order to make the improve the accuracy, I need to do a lot of transformation, and also I need to visualize data and see what are the related variable, like for example visualize the correlation matrix and see what are the most impactable parameters when I'm going to build this machine learning model. But in here for the demo purpose, I just grabbed a few variables from the data set and I created the machine learning model. The whole purpose is to show you how easily you can build this using machine learning services in SQL Server. So let me go back to my slides. Okay, so that's it for the demo. So let me check, is there any questions you have, so I will be able to answer.
Hi everyone. If there are any questions, you can just ping and ask. I think Nisal, there is one question.
Yeah. The question would be, the processing load now rests entirely on SQL Server machine. We need do we need a very high specification on SQL Server mesh? Okay, the simple answer for that is actually it's depend on your workload. So basically, it's also depend on your configuration. So if your data set is high volume data set, or if your I mean the model you are going to achieve is a with a very complex model with many variables and many observations, then obviously you need to consider about this to have a high end server. And again, the good thing is, like I said, that Revo SQL R package in the machine learning services, they like I said, they push the limits of having single threaded processing. So even a very large volume, for example, let's say I'm going, I'm uh, I'm working as alone with creating predictive models and various experiments. Let's say I need to implement a machine learning model, but the thing is, my machine is 8 GB, or my machine RAM is 16 or 12 GB. So still it's possible, because using Revo SQL R packages, so you can actually, it's in the MSDN documentation, so you can refer that. You can use those libraries. You can install R client in your machine, which is come with the SQL Server. So using that, it's basically what it does. It's splitting the data and do the batch processing. Even though the data volume is higher than your available configuration, it's still possible to do that. So this is alternative solution for the if you're not uh, planning to move to the cloud and do the machine learning predictive modeling stuff using Azure Databricks or so on. So you can use machine learning services or machine learning server to do that in your on-prem.
Is there any other question?
The rest, I mean, latter part of this question is, my concern is the during the model training, the SQL Server slow down. Usually when training the model, we can leverage GPU. Can SQL Server incorporate that these things? So basically, for the anyway, it is not. So if you can remember, my I explained that extensibility architecture. Uh, from the SQL Server does what it does, only executing this and passing this data into the separate service. That service is isolatedly running behind a background, in the background, that extensibility services, machine learning services. So even let's say, even though that service is blows up, it is not impact to your SQL Server machine, because it is separated from the SQL Server. So in that way, you don't need to worry about. Only thing is, you before you run it in the production, I mean, in the environment, in your dev environment, you need to look at how the performance impact with your current workload. So there's another question: uh, how you handle the model drift in this case. So I'm not Najinder, I'm not very clear about your question. Can you explain more?
Yeah, Nishal. So essentially, what I'm trying to ask is, over a period of time,
Mm-hmm.
when your data set changes or the training data set kind of explodes with new data coming in, your
Yeah,
model accuracy might go down, right? So how do you
yeah,
handle that kind of, essentially, in machine learning world, people call that as ML ops or DevOps, right? And for machine learning, how do you integrate that in SQL Server?
yeah. So that also possible, because here, if you can remember what we have used to invoke these machine learning or predict commands using T-SQL. So similar way, we are using normal standard day-to-day database workload, that continuous integration and continuous delivery. So similar pattern we can use with the new data set. We can continuously train this model and check the accuracy based on that, deploy that into the production. We can build a
Okay,
whole entire ecosystem like that, since we are using standard ways to call these uh, machine learning services using SQL Server via stored procedures. That is my understanding of how I do that.
got it. Thanks. Thanks. So I believe these notebooks can be scheduled to run at a certain time to
Yeah,
do the retraining and all that.
yeah.
Okay, great. Thanks. Excellent demo. Thank you.
Uh,
Okay, thank you.
Thanks, Nisal, for this presentation, and it's really nice.